When potassium chromate is added to copper sulfate solution, there is the formation of copper chromate as well as dichromate. Formation of copper chromate, dichromate is due to, dear students, dichromate ions, when dissolved in water, exist as an equilibrium mixture of chromate ions and dichromate ions. Now, if the medium is made acidic, the equilibrium will shift in the backward direction. You will have dichromate which has got orange color. And if the medium is made alkaline, that is a pH is more than 7, then the H ions will be consumed. So equilibrium will shift in the forward direction and you will have yellow color. So copper sulfate solution is a salt of a weak base strong acid. Hence, due to cationic hydrolysis, copper ions will react with water to give you copper hydroxide and H ions, and the solution will be acidic. That is, the pH will be less than 7. As a result, this equilibrium will shift in the backward direction. So you will have dichromate ions as well as chromate ions. So in the solution, this formation of copper dichromate is due to acidic nature of copper sulfate. Potassium dichromate gives colored solution in water. This is due to, we know a solution will be colored if it contains unpaired electron. But compounds like potassium dichromate and potassium permanganate are present, since they are present in the highest oxidation state, they don't have any unpaired electron, but then too they are colored. In the case of dichromate ion, the color is due to the charge transfer from oxygen to chromium. So whether it is dichromate or it is permanganate, MnO4 minus, or even in the case of lead iodide, the color is due to charge transfer. So the answer will be third. Now, we know that if we take KCN and add it to excess of ferrous cyanide, you will get K4FeCN whole 6. In this compound, we cannot test for ferrous. Such compounds where the test of iron cannot be done. If you dissolve it in water, FeCN whole 6 will exist as such. Whereas in the case of more salt, you can test for ferrous. K4FeCN6 is known as a coordination compound or a complex salt. More salt is a double salt. In the case of complex salt, we cannot test for the ions which are written within brackets because these ions are held together by cyanides. When dissolved in water, they do not dissociate. So, in the compound like this, the square bracket indicates the coordination sphere. 6 number, that is coordination number. Cyanide is a ligand, iron is a metal atom. In order to neutralize these, we sometimes write the ion outside the bracket. That is called the counter ion. Ligand is nothing but a Lewis base. It has a lone pair of electron, which it gives to the metal atom. Now let us study a few questions in order to clarify this chapter. Which of the following ligand, if present, can form a chelate? Chelate is a cyclic complex. If the ligand has two different donor atoms and it can form a 5-membered or a 6-membered ring, then the cyclic complex so formed is known as chelate. So ethylene diamine tetraacetate is a ligand which can form chelate because it has a number of donor atoms. In this case, the number of donor atoms are 6. Ethylene diamine tetraacetate. So tetraacetate means 4 acetate groups are also there. As a result, it can behave as a multidentate ligand. So it forms a cyclic complex. Catch hold of the central atom at more than 2 points. So the answer will be ethylene EDTA, ethylene diamine tetraacetate. Other examples of this type are ethylene diamine, oxalato, glycinato, cyanide. The next, this is a ambidentate ligand because there are two different donor atoms, but it cannot form a cyclic complex. Carbon monoxide, it is a type of ligand which not only donates the lone pair of electron but also accepts the lone pair of electron. So it is not only a donor but also a acceptor. Such a ligand which can donate as well as accept a lone pair of electron is known as pi acid ligand. Fluoride is another ligand. So out of these 4 ligands which he has given to you, dear students, EDTA is a polydentate ligand. It can form a chelate. Cyanide is a ambidentate ligand because it has 2 different donor atoms. Carbon monoxide is a ligand which not only donates but also accepts the electron pair. So it is a pi acid ligand, and fluoride is a simple ligand, monodentate ligand. Which of the following ligand, if present, can give rise to linkage isomerism? Linkage isomerism is given by those compounds, by those ligands which have two different donor atoms. So it can be cyanide, it can be SCN minus, it can be nitro. Even the phenoxide ion is also a ambidentate ligand because the lone pair of electron gets delocalized over the ring also. So the attack can be oxygen on the oxygen as well as carbon of ortho and para position. So out of these choices, the answer will be SCN minus. NH4 plus is not a ligand because it does not have a lone pair of electron. Had it been ammonia, that has a lone pair of electron that can act as a ligand. Oh, hydroxide ion is a ligand, carbon monoxide is a ligand, but SCN has two different donor atoms, sulfide, sulfur and nitrogen. So the bonding can take place from 2 points, hence it gives rise to linkage isomerism. Only the ambidentate ligand can give rise to linkage isomerism. Which of the following complex will have highest molar conductivity? The conductivity depends upon number of ions. Greater the number of ions given by 1 mole, greater will be the conductivity. The first choice can give you 4 ions, so its conductivity will be more. Second will give you 2, its conductivity will be less than first. Third can give 3, its conductivity will also be less than 4. If I compare the conductivity, then I can say 1 will be greater than 2 will be greater than 1 will be greater than third will be greater than 2. Fourth is a non-electrolyte because it does not ionize. Then